Chapter 7, Confidence Interval. Section 7.1, Confidence Interval for estimating a population mean with standard deviation is known. We know about the population standard deviation and we want to find the confidence interval for the population mean. Definition: point estimate is a single value used to approximate a population parameter. So the point estimate, it can be the sample mean. We use the sample mean to approximate the population mean. Or it can be the sample proportion. We use the sample proportion to approximate the population proportion. Confidence interval. Confidence interval is a range of the values used to estimate the true value of a population parameter. This is the confidence interval for the population mean. And after we figure out what is the numbers here, we will believe that the true value of the population parameter will be lying on this range. And for the chapter 7, we will be construct the confidence interval for the population mean, and we will construct the confidence interval for the population proportion. Now let's look at this example. We were interested in the mean weight of all apples in the farm. Since it is impractical to weight all the apples in the farm, we took a sample and found the mean weight. So for example, I'm gonna cut out this part as my sample. And then I try to measure the weight of the apple and then add it up all together, divided by the number of the apples here. And we find it out, sample mean equal to 149 grams. And we call this is gonna be the point estimate, right? A single value, point estimate. And we will be using the sample mean to approximate the population mean. So we believe that population mean is about 149 grams. Right? This is what we covered on the chapter 3. But think about it. If I draw this part, that's a 149 gram. How about if I draw this part have the sample? I may get like a slightly different. I may get the sample mean 130 gram, or I may get the mean is gonna be 153 gram. Right? So it will never be a perfect representation of the population, because different samples of the same population will give different results, right? And we call this is going to be sampling error. So what we're going to do, instead of use the sample mean to approximate the population mean, we will be construct the confidence interval. Instead of using a single value, we'll be use a range of the values to approximate the population mean. Confidence interval provides more information than point estimate. Confidence interval for means are the intervals constructed using a procedure that will contain the population mean a specific proportion of the time, typically either 90%, 95%, or 99% of the time. So this one, I do have a 1 point here, and we call this is going to be the point estimate, right? The sample mean. If I try to working on the 90%, okay, 90% talking about will be in the middle part. This is gonna be 90%. And I will try to construct the confidence interval. Instead of one single value, I'll be using a range of the values. Okay, and when I say 90% confidence interval, talking about that will be in the area in the middle, that will be 90%. Or we could construct 95% confidence interval. Then you're gonna see the range of the values will be wider compared with the 90% in here. Because like we take more area from here, 95% in the middle now. Okay, how about 99%? 99%, then the confidence interval, the range of the values will be much wider compared with 95 and 90%. Okay? After we construct the confidence interval, we could draw the conclusion. We do have 90-something% confident that the true values, talking about the population mean, lies within this interval. Okay, so you could get the idea that point estimate, talking about the sample mean, a single value to estimate the population mean. When we have a 90% confidence interval, we do have a range of the values. We do have a 90% confidence that the population means is going to be lying within this interval. When you increase the confidence level from 90 to 99, you will have a more chance to including the true values in here. Okay, from the point here, from the point estimate to the side here, we call this is E, which is going to be your margin of error. Okay, margin of error. So how can we construct the confidence interval for population mean? We'll be using the point estimate, the sample mean plus minus the margin of error. Then we will get a range of this part of the values. Okay, right? I just give you guys the idea what is the confidence interval and what is the confidence level. Okay, confidence level is the probability that 1 minus alpha, that the confidence interval actually does contain the population parameter. Assuming that the estimation process is repeat a large number of times. Okay, for example, if I'm working on 95% confidence level, 95%, that become 0.95. And what is alpha? Alpha is talking about area of the left tail, plus area of the right tail. That would be equal to alpha. So I know the total area under the curve, that's going to be equal to 1. Okay, so how can I find my alpha? Alpha will be equal to 1, the total area, minus in the middle part, which is going to be 0.95. That will be equal to 0.05. And since I do have a 2 tails, so I'm going to be divided by 2. You should get 0.025. So each area for the left tail and the right tail, that will be 0.025. You could try to add it up. Add up this 3 number is supposed to be equal to 1. Remember on the chapter 6, we talk about it. Total area under the curve has to be equal to 1. Okay, right? I need you guys to know how to find the area for the each tail. And then critical value, highlight the critical value. Critical value is the number on the bottom line separating sample statistics that are likely to occur from those that are unlikely to occur. The number z alpha over 2 is a critical value that is a z-score with the property that it separates an area of alpha over 2 in the y tail of the standard normal distribution. So which one is going to be my critical value? Talking about the y tail, the z-score alpha over 2, this is called the critical value. And this line, that will be separating the sample statistic. Okay, for example, if this is a 95% confidence level, okay, this is going to be 95%. And this line will be separate. This is likely to occur and unlikely to occur. Okay, I want you guys circle it. Critical value is always on your y tail. It's always positive in this case. It's always positive. So first step, we need to know how to find the critical values. Let's do it together. Find the critical values for the confidence level of 98%. So we're assuming 98% is going to be in the middle here, right? 0.98. And then we try to looking for the area for each tail, right? Which is going to be your alpha. right? So what we're gonna do, I try to find the area of each tail. So I'm gonna do alpha divided by 2. And alpha, remember, total area 1 minus 0.98 divided by 2. So you're gonna get 0.01 for each area. Okay, add it up, 0.01 plus 0.01 plus 0.98, which is gonna be equal to 1. So I'm good. And then I want to find the critical values. Again, critical values, talking about the z-score on your y tail here. Okay, and I know this is gonna be 0.01. So the area from the left, that would be 0.99. So on the chapter 6, we learned that when they given the area, how can you find the z-score? We'll be using the inverse norm area from the left, right? The total area including the left tail, that's 0.99. Use your calculator, you're gonna get 2.33. So my critical value for the 98% confidence level, that will be 2.33. Okay, another example, 95% confidence interval. I want you guys try to do it by yourself. Find the critical values for a confidence level of 95%. Okay, let's do it together. So 95% in the middle, that will be 0.95. Then figure out the area of each tail. So alpha over 2 equal to 1 minus 0.95 divided by 2. You could get 0.025. Now, critical value will be on your y tail, right? This is what we're looking for. So area from the left, including the left tail, that will be 0.975. So inverse norm, 0.975. Use your calculator. You're gonna get 1.96. Okay. So critical value for the confidence level 95% will be 1.96. On the exam, I don't need you guys to draw this graph and this part here. On the exam, I only need you guys to show this part. I need this one for your test. Okay, state the z critical value using the inverse norm, what you put for the area from the left, and then the final answer here. Okay, construct the confidence interval for the single unknown population mean. We need the sample mean as an estimate for the population mean, and we need the margin of the error, okay, denoted by E. We need to know how to find the margin of error. Margin of error, that will be equal to critical value, you guys just did on the example 1, example 2, times the standard error. Okay, remember on the chapter 6, session 6.3, we were on this guy, right? The standard error. This is how you guys find the margin of error. And the margin of the error is the difference between the statistic and the endpoints of the interval. For example, if the statistic were 0.6 and the confidence interval range from 0.4 to 0.8, then the margin of the error could be 0.2. So let me state all the information here. I assume the statistic is going to be my sample mean 0.6. And then my confidence interval, that is from 0.4 to 0.8. So the picture is gonna be looks like this. Sample mean, that will be 0.6. And then the end point will be 0.4, and then the 0.8 here. And remember, what is the margin of error? That is from the sample statistic to the end point, right? So this is gonna be your margin of error. When you subtract it, that will be equal to 0.2. Same idea for this guy. Okay, so if you know the sample mean, you know the margin of error, you should be able to construct the confidence interval. Okay, confidence interval for estimating population mean with population standard deviation is known. So this guy is gonna be given. And then we'll be using the Z distribution, just like the chapter 6, Z distribution. First, what is a Z distribution? It is a symmetric bell-shaped curve. And then spread of the distribution is standardized. Right? This is the Z distribution. And then requirements. When we construct the confidence interval, we need to fulfill the requirement. First, simple random sample. And then the value of the population standard deviation is known. This is given. Okay, sometimes they will given the same post standard deviation. Okay, then we don't use the Z distribution. Okay, we're gonna talk about it for the next sessions. Number 3, either or both of these conditions are satisfied. Population is normally distributed, or sample size that's be greater than or equal to 30. Okay, remember on the session 6.3, we want to apply the central limit theorem. So it has to be fulfilled this 3 requirement here. Verify the required assumptions are satisfied. Then, after we verify the requirement, we want to find the critical value, just like the example 1 and example 2. And then we want to find the margin of error. So after you find the critical value, plug in here. And we need the population standard deviation. Step 3, we're gonna construct the confidence interval. Okay, you can write it like in the inequality, or you can write it like population mean equal to sample mean minus E and the sample mean plus E. Okay, either way. And then number 4, you're gonna draw the conclusion. Okay, so follow these 5 steps. The first one has to be verify the requirement. Find the critical value, margin of error, construct confidence interval, and then at the end, you're going to draw the conclusion. Okay, let's try to do the example together. The mean test score for a simple random sample, n equal to 100 students, was sample mean equal to 67.3. Population standard deviation, okay, population standard deviation of test score is equal to 15. Construct a 99% confidence interval for the population mean test score. Okay, we do have a population standard deviation. So good. First, simple random sample. And then sample size is greater than 30, which is going to be 100. So we'll verify the condition. Then find the critical value. Okay, just like example 1 and example 2, we want to construct 99%. Okay, 99%. I want you guys try to do it by yourself. Okay, find the critical value. So 99%. Using the inverse norm, including the area from the left, it should be 0.995. Okay, you should get 2.58. Hey, this part is very important. If you make a mistake for this part, you will make a mistake for the step 2 and step 3 also. Okay, so review it on the example 1 and 2. How can you figure out this number? Okay, I need the whole thing here for the test. Now, find the margin of error. So you already have the critical value, population standard deviation, that will be equal to 15. And then sample size, n equal to 100. Okay, use your calculator to see what you guys get. So you're gonna get 3.87. Okay. And then construct the confidence interval. Okay, we are working on the population mean. We have the sample mean 67.3. And then we find the margin error from the step 2 here. Okay, so try plus minus the margin of error. Okay, you're gonna get 63.43 to 71.16. Conclusion. Okay, you guys need to know how to draw your conclusion. We are working on the 99% confidence interval. We will say we are 99% confident that population mean test score will be copying from here is between these two numbers. I need complete sentence on your test. Okay? Okay. Here will be the instruction how to use your TI-84 calculator. Okay, let's try to do it together. Okay, go to stat here. Go to the test. Okay, use the white arrow button. Go to the test. Then go to the Z interval. This is talking about Z distribution confidence interval. Enter. And then from our example, we are giving the statistics summary. Okay, statistics summary means they already give you the sample mean and the population standard deviation. Okay, if they give you a list of the data, then you may want to choose the data, but you need to input the data on your L1 first. Okay, so population standard deviation is 15, sample mean 67.3, sample size 100, and then we are working on 99%. Put the decimal here, 0.99, and then calculate. Okay, scroll down and then we're gonna click calculate, enter. So you're gonna see confidence interval 63.43, 71.16. Okay, we have the sample mean and the sample size. So you always can check your work for your quiz and also the test. For the test, I need you guys show me all your work, okay, just like this. But you always can double check your answer here. So make sure take advantage of using this calculator. Okay, another example. I want you guys try to do it by yourself. Okay, check the condition, find the critical value, plug into the margin of error, and then construct the confidence interval. Okay, try your work. When you guys highlight this here, population standard deviation of 3 points. Okay, population standard deviation is given and is equal to 3. So first, check the condition. Simple random sample. Okay, and then they do have the original population is normally distributed. And also sample size is greater than 30, right? Find the critical value. We are working on the 90%. Okay, so you have 1 minus 0.90 divided by 2 and then plus 0.90, which is this guy. You should get 1.645, okay, 1 to 3 decimal space. And then state the margin of error, population standard deviation, that will be 3 points equal to 3, and will be equal to 36. So you should get 0.8225. Now, construct the confidence interval. Okay, you have the sample mean 68 plus minus the margin of error. So you should get this. Okay, and then state the condition. We are 90% confident that the population mean of the statistic exam score is between these two numbers. And use your calculator, okay? Use your calculator, plug in the information to see if you get these two numbers. Okay, then after we construct the confidence interval, we want to determine the sample size for estimating the mean with the population standard deviation is known. Okay, you will have this formula. Sample size n, the critical value, times population standard deviation, and then divided by the margin of error. Okay, and then sample size is always a whole number. I want you guys to try to round up to the nearest whole number. Always round it up, okay? Okay, let's try to do this example together. Scientists want to estimate the mean weight of mice after they have been fed a special diet. From previous studies, it is known that the weight is normally distributed with the standard deviation 3 grams. So we know the standard deviation is going to be equal to 3. How many mice must be weighed so that a 92% confidence interval will have the margin of error of 0.5 gram? So we know the population standard deviation, we know the margin of error. Okay, so first, figure out the critical value with the 92%. You're gonna do 1 minus 0.92 divided by 2, and then plus 0.92, which is gonna be 0.96 here. Okay? And then 1.75. Now, we're gonna use this formula. Plug it in. Try. What did you guys get? You're gonna have a 110.25. Remember, always round it up because there's a sample size for the mice, right? So the final answer will be 111. So these sessions, we talk about how to construct confidence interval for the population mean when we have the population standard deviation, and also how to determine the sample size. Okay, that's it.